Hello, I'm here today to talk about unsupervised evaluation of interactive dialogue with DialogGPT. My name is Shikib Mehri, and this work was done at CMU with my advisor, Maxine Eskenazi. Evaluation methodologies shape the direction of research. They're used to compare between systems, which determines what gets published, and they're used to identify the weaknesses of systems, which determines what the research community works on. However, for Dialog, our current evaluation methodology has certain flaws. Dialog is meant to be inherently interactive. Dialog systems are designed to have a back and forth interaction with the real user. However, to date, research has largely focused on static corpora, and this reduces the problem of dialogue to that of response generation. Unfortunately, with a static dataset, some properties of dialog systems can't be effectively assessed, and for certain properties, you need an interactive environment to really assess them. This includes things like long-term planning, error recovery, and coherence. Furthermore, dialog quality is multifaceted. A response isn't just good or bad, and you can't reduce the complex idea of dialog quality to a single number. Especially for the purposes of interpretability, we should be measuring multiple different qualities of dialogue, including things like relevance, consistency, and fluency. So evaluation is important because it shapes the research direction of a field. We should be evaluating dialogue in an interactive manner, and we should be assessing several different aspects of dialogue quality. And one thing that I really want to emphasize here is that the only perfect evaluation mechanism is human evaluation. If you have a dialogue system and you really want to get a sense of its quality, you should be performing human evaluation. But human evaluation is both time-consuming and costly. And as such, there are certain scenarios where human evaluation is not feasible. This includes things like during development. For example, if we're doing hyperparameter tuning, it's infeasible to be consistently running human evaluation. For large-scale analysis, like if we want to identify erroneous dialogues, we need an automatic metric. In this paper, we present fine-grained evaluation of dialogue. We first take a collection of interactive dialogues released by Ariwardana et al. This includes dialogues between humans and Mina, humans and Mitsuku, and humans. We annotate these interactive dialogues for 18 different dialogue qualities, which is called the fed dataset. We then present an evaluation metric that captures these 18 different dialogue qualities, and we call this the fed metric. Here's a list of all the dialogue qualities that we capture. At the turn level, we capture things like interesting, engaging, relevant, fluently written, and at the dialogue level, there's qualities like coherence, consistency, diversity, the adaptability of the system, whether it's inquisitive. And to create the set of qualities, what we did was we looked at the literature and we looked at the metrics and the qualities that people used to assess their systems. We tried to collect as many different qualities as possible so that we have a wide range of qualities and a diverse set of qualities. So we took interactive dialogues and we annotated 124 different dialogues. For each dialogue, we asked 3 turn-level questionnaires. So basically, we assessed 3 different turns. And given that there's 9 turn-level qualities, this gave us a little bit over 3,000 turn-level data points. We also asked 1 dialogue-level questionnaire. And given that there are 11 dialogue-level qualities, this gave us 1,300 data points at the dialogue level. Everything was annotated by 5 different annotators. To give a sense of the results, at the turn level, we see that Mina outperforms humans, and then humans and Mitsuku are roughly at the same level. And what this suggests is that at least for the task of generating responses, Mina has surpassed humans' ability through large-scale pre-training. Because we collect several different fine-grained qualities at the turn level, and then also ask for an overall impression, we can determine which fine-grained qualities most contribute to the overall impression. And what we find is that for our annotators, interesting, relevance, and fluency contributes most to their overall impression at the turn level. At the dialogue level, we see that humans outperform Mina and Mina outperforms Mitsuko. And this result really highlights the importance of assessing systems in an interactive environment. If we were just looking at the static task of response generation, we would think that Mina has surpassed humans. But now looking at an interactive dialogue where the system has to have a back and forth interaction, we see that humans still outperform Mina and Mitsuko. At the dialogue level, the qualities that contribute most to the overall impression are coherence, likable, which includes things like personality and empathy, and also whether the system understands the user. So how do we go about developing a metric? First of all, there's no training data because the fed dataset is a set of human judgments that we use to assess our metric by correlating it with human judgments. So no training data. We don't have a reference response because this is an interactive setting. And we need to capture 18 different dialogue qualities. To explain how we go about developing the fed metric, there's two pieces of prior work that I want to discuss. In 2019, as part of Eskenazi et al., we did some work where we found that the next user utterance is especially important for evaluating dialogue systems. For example, if the user says, "How are you today? I was just watching the football game," and the system responds with, "Did you know cats sleep for 18 hours a day?" then the user responds with, "Huh? That's not relevant at all." By looking at the user utterance that's following the system response, we can get a sense of how good the system response was. And as part of Eskenazi et al., we did this for task-oriented dialogues, and we found that often, by looking at the next user response, we could better evaluate, both in terms of annotation and in terms of modeling, how good the last system response was. But in open domain dialogue, what are the odds that the user says something useful in their next response? For open domain dialogue, if we just rely on the user calling out a mistake of the system, we might only capture the worst of the worst system responses. The next piece of prior work is that large pre-trained language models, such as BERT, have been shown to implicitly capture world knowledge. In Levesque et al., they showed that BERT captures some notion of common sense. DialogGPT has claimed human-level response generation capability, and given the results that we saw from our annotation of Mina's conversations, this might very well be true. So now the hypothesis here is that DialogGPT has implicitly captured some notion of dialogue quality in the process of learning how to generate good responses. And now linking together the first piece of prior work in Eskenazi et al. With this idea of DialogGPT capturing some notion of dialogue quality, we think that we might be able to use DialogGPT in place of the next human utterance. And this is the fed metric. So given the dialogue history, which includes the response that we want to evaluate, we compute the likelihood using DialogGPT of generating a positive follow-up utterance versus a negative follow-up utterance. So for example, if the system said that, "Did you know cats sleep for 18 hours a day?" we compute the likelihood of DialogGPT in the place of the user generating "cool, very relevant" versus "that's not relevant." And the idea here is that because DialogGPT has attained human-level response generation capability, it knows that it should generate the positive utterance in a situation where the last system response was relevant, and it should generate the negative follow-up utterance in a situation where the last system response was irrelevant. We take the difference of the positive score versus the negative score, and this tells us how relevant the last system response was. So for the fed metric, we write a set of positive and negative follow-up utterances for each one of the 18 different dialogue qualities. For example, for interesting, one of our positive utterances is, "Wow, that's so interesting." And one of our negative utterances is, "That's really boring." And the model, DialogGPT, because it's so good at generating responses, should know that one of these responses is better to generate when the last system response was interesting, and another one is better to generate when the last system response was not interesting. To compute the overall impression of both the turn level and the dialogue level, we take the average of all the fine-grained scores. we evaluate 4 different variations of the DialogGPT model, both medium and large models, and models that were fine-tuned from GPT-2 or trained from scratch. For the turn level qualities, we attain correlations between 0.11 and 0.43. The highest correlations are for qualities like interesting, engaging, and specific. Our overall turn level correlation is 0.21. For dialogue level, we see correlations between 0.25 and 0.52. The highest correlations are for topic depth, diversity, and informativeness. And the overall dialogue level quality is 0.44. And while there's still a lot of room for improvement here, I think that these results are still fairly impressive because they were done without training data and without any fine-tuning on in-domain conversations. Really what this shows is that DialogGPT has in fact implicitly captured some notion of quality, and that by using the strategy with the follow-up utterances, we are able to extract out some of this idea of dialogue quality. To summarize the contributions of this paper, we developed FED, which is an unsupervised fine-grained evaluation metric that measures multiple fine-grained qualities of dialogue, exhibits strong correlation with human judgments, and because it relies on no training data and only requires follow-up utterances, it can easily be scaled up to other dialogue qualities. We released the FED dataset to facilitate the development and assessment of new evaluation metrics. We also open sourced the code for FED, and it's honestly really easy to use. Really all you need to do is you load in the model, you specify the conversation, and you get back a dictionary that consists of all of the dialogue qualities. Thank you.